Chapter 2: Digital Signal Processing. This chapter explains where a DSP system is located in a real application, how DFT and IDFT are computed, and how they are related to Fourier transform. Also, some of their properties are investigated. A DSP system. Figure 2.1 illustrates the block diagram of a real-world system including a DSP. An analog input x of t. In order to limit the frequency bandwidth, passes through a low-pass filter, which is denoted as V of t. Okay? Then the output signal of the filter is sampled and quantized by an ADC, and it's called V of n times Ts. The signal is processed by a digital circuit, normally a conventional computer or specific DSP boards, and then the processed signal is converted back into an analog signal using a DAC. Then the analog signal, having stepwise form, is softened by a reconstruction filter or anti-imaging filter or smoothing filter. What about the benefits of using DSP? It allows for more complex processing than the similar analog environment. Due to digital process, it provides better signal quality and repeatable performance. It's more complex, as most digital processing can be changed easily, say for example by updating the software. And for the same performance as analog, it usually results in a lower price. It is less sensitive to tolerance and environmental changes. It is possible to have mass production without the need for adjustments when using, while analog definitely needs to be adjusted. And it's easier and cheaper to make integrated circuits for digital than for analog, while it's difficult to make analog processing circuits, especially circuits containing inductors with large inductance, and they cannot be designed as an integrated circuit. And moreover, the accuracy of the digital system can be increased by increasing the word length, which of course it increases the price. The dynamic range can be increased using floating point computations or calculations, where the dynamic range of the analog system is limited to the power supply. And a digital processor can be used in the form of timeshare for different operations, which is called multi-job. This advantage is not possible in the analog system due to the continuous nature of the signal. And moreover, a digital processor can simply be adjusted by changing the coefficients, which may be used in adaptive filtering, while this idea is not easily realized in the analog system. And it's possible to have true linear phase for a digital system, while linear phase cannot be created in analog. And multi-rate is possible for digital system. However, it's impossible in analog system. And digital information can be easily stored on tape or disk or other types of memory for later usage. It's possible to perform the required processes digitally and at a very low frequencies, while due to the large size of the inductor and capacitor, this is not possible in analog prototype. Okay, what about Disadvantages of using DSP. The biggest disadvantage of DSP techniques is that they are limited to low bandwidth signals. Currently, DSP systems are used for signals up to the bandwidth of video and baseband telecommunications. Digital system is more complex than analog one, needs sample and hold ADC, DAC, and the cost of implementing a high-speed ADC and DAC is very high and almost impractical for many applications. As the sampling frequency increases, the ADC resolution comes down. For example, with fs equals to 1 GHz, the resolution of ADC is reduced to 6 bits. The same idea for DAC. And the high power consumptions and size of a DSP implementation make it unsuitable for very low power or small size applications. For example, a digital processor with 400,000 transistors consumes about 1 watt of power, while an analog filter with capacitors and inductors and even with resistors with similar frequency requires for far less power. Of course, it should be noted that nowadays researchers are trying to lower the power consumption of digital systems, which has applications in portable devices and medical engineering, especially when the system is supposed to be placed inside the human body. In this case, a small battery is sufficient for the intended duration. Now, what about common applications of DSP? Switch compression for storage or telecommunications applications such as cellular telephone systems, VoIP, etc. CD, DVD, application in modems including digital filtering, modulations, echo cancellation, and image enhancement and compression, speech production, applications in biomedical engineering, electronic warfare, improving target detection algorithms in radar systems,